If a picture's worth 1,000 words, a prototype is worth 1,000 pictures. Hi, my name's Devereaux. I'm the founder of Serafina. As an innovation engineering firm, we solve very, very difficult problems, and often it means building prototypes for my clients. A lot of my clients are military or law enforcement, so let me show you a fun project I worked on about 6 years ago. Diode lasers became commercially available in the 1980s, and as a kid, I was obsessed with the sharper image. For a cool $100, you could be an executive and point to your presentation with a laser and feel like Gordon Gekko at the same time. As this component became a fungible part over the next decade, it didn't take long for 650 nanometer lasers to make their way in everything from cat toys to laser assists for firearms. For the last few decades, everyone's been pretty satisfied with a laser dot as an aiming support system, but it really has unspoken problems. While long-range optics, like for sniper rifles, have milled dots and laser rangefinders, there's no real equivalent of that when you have milliseconds to shoot within meters. First problem, to the operator, a dot is essentially one-dimensional. It has no height, depth, or width. Second problem, in certain environments with weather and dust, laser imaging devices are two-way. They also point the adversary to you. That could be a problem. In 2020, I was in Los Angeles and I had this client project that presented a unique challenge. How do I dimensionalize a target for an operator to quickly make height, width, and depth determinations at the same time obfuscate their position? So the prototype I developed was a laser reticle, and some interesting features came out through the rapid prototyping process. With an adjustable choke, it was easy to set standard ranges for a specific use case. As an airborne crosshair, height and width determination are visually communicated as an overlay on target. Having planes of laser light instead of a single line actually helped mask the location of the operator when entering a room. And finally, unlike a dot that doesn't have a clear up or down, we put the reticle in a floating gimbal so it always points up, and that was key. So in summary, this is not a video about firearms. This is a video about how if I told you about a laser reticle, you might not care. But if I demonstrated the problem with the status quo and then prototyped an alternative, now we're on the next curve together, and that's what innovation's all about.